Hello and welcome to the lecture Multimodal Deep Learning. In this lecture, we are going to discuss what is multimodality. Then we discuss the different points for multimodal analysis and modeling. It is research oriented definition, dimension of modality heterogeneity, modality connection and interaction. Then we discuss core technical issues and conceptual challenges by discussing representation, alignment, reasoning, then generation, transference and quantification. In our daily life, when we are sharing thoughts, understanding things, and when we discuss something or we try to express our thoughts or thinking, generally we see that our behaviors are typically multimodal. And to express our behavior or to represent our behavior, the signals that may be acoustic signals, that may be visual signals, that means some physiological signals, or something, some electro or electrical or electronics machinery that use. So these our behavioral signals are not a single modality. It's a multimodal in nature. So why it is multimodal? That means if you think about when we are talking or discussing, there is a one representation maybe through words. Again, within words, there is some sort of syntax. So there is some syntactical representation, that's a parts of speech, dependencies between words or grammatical or syntactical relations between words and so on. So language itself may be thought of a bigger modality or there is some submodalities. Similarly, in acoustic, intonation, that means how we are speaking, that means voice quality, some vocal expression like laughter, moves. So this is the different types of way we express our thoughts. So when we are human being is connecting to some event or connecting to each other or sharing our thoughts, the way of our communication is multimodal in nature. Same as visual, we use some gesture, maybe head gesture or eye gestures, arm gestures and so on. Body language, eye contacts, facial expressions. So these are the different way we basically use to more sensibly express our thoughts. Similarly, this in touch, that is haptics, motions, some physiological skin conductance, electrocardiogram, or we use so many now electronic devices like laptop, mobile and so on. So GPS location, accelerometer, light sensors and so on. So what we understood that the human interactions or sharing thoughts or understanding something in general not depend a single model, rather it inherently multimodal. Now, first of all, understand what is modality. So modality by definition refers the way in which something is being expressed or perceived. When we say something, express our thoughts, so there is some way, maybe with a very simplistic thinking, we can show an image or we say some sentence, or you can sing a song. So the way of expression may be different. So different modalities. Similarly perceived, when we try to understand, we can read the article, we can see an image, we can view a video, and so on. So modality refers the way in which something is being expressed or being perceived. Now, there is, if you understand the different types of modalities, or better to say, what are the nature of modalities? That's if we say the raw modalities, that's speech signal when we are talking or on seeing an image. It is very closest or close to the sensor, so that it is somewhat raw in nature. But if you going further in a distance from the sensor, the level of abstraction is being increased. That when we see a speech signal, then it just we hear that signal. Now again, a language is what? Language is that this particular signal, it's spoken to in some language. There is some syntactical or semantical rules. There may be some sentence, maybe some text, maybe paragraph, maybe some, you can say, some description. So it is a language. Now if you go more further from the sensor, it may be a sentiment or intensity of the sentiment. It's a more abstract modalities. It is furthest from sensor. Similarly, in case of image, it's a raw image, the matrix of the pixel values. Now if we go further, we can detect objects there. So objects within the figure. And now more, if we go more further, there's the object categories, the levels of objects. So this modalities is defined in this way, and a very simplistic or naive way of defining modalities is like this. So by dictionary definition, multimodal means with multiple modalities. Now one thing please try to understand in this course, when we are talking about NLP, it is about text most of the time. When we say vision, it is about image, video, something. But in a very less situation, we said both. The question is, when we try to understand the research-oriented definition of multimodal, then that multimodal is a scientific study of heterogeneous and interconnected data. Now heterogeneous, why? What I said, that if we simultaneously take image and text, just for example, or image and audio, or text and video, and so on. These data are somewhat interconnected. That means they're connected and may be interacting. So analysis or kind of dealing with multimodal data in a scientific way is that the study of heterogeneous and interconnected data, and that is multimodality. Now, why it is matter? Why multimodal is important from our scientific viewpoint, or you can say research viewpoint or academic viewpoint? That is it, why it is required, why only vision models or deep learning models for vision, deep learning model for NLP may not be enough? Why there is some deep learning models is required where not only vision, not only NLP, but both or many more? So, as we have discussed it, our nature, our perception, our cognition is a multimodal or inherently multimodal. So, if we say the faithfulness means how can we depend on the data or experience? We are not depends on our ear. We only believe if we see it, we can touch it, we can taste it, we can somewhat get some smells. Very hypothetically, maybe all not possible. But the confidence of the data or information is increased with multimodal expressions or experience. So human experience is multimodal in nature. In practical situation, we see the internet or many applications are multimodal. In internet, we are not only dealing with text, it is images, videos, and many other different data of different modalities. So in practical case also we get it's a multimodal nature. Another very interesting thing is called data efficiency and availability. Efficiency in what sense? Multimodal data is rich and high bandwidth. Here a very interesting quote has been given compared to language. Professor Lekun said that an imperfect, incomplete that language is saying, and low bandwidth serialization protocol for the internal data structure we call thoughts. But multimodal data is much sensible, much better for learning. So that's why the multimodal matters. Scaling means more data is better, and we are running out of high quality text data. So if a particular event, let's say a medical image, if we see only X-ray plates, that may not be very good. diagnosis thing. But with this, if we get another modality, let's say MRI or CT scan, or plus some meta information or kind of blood reports and so on, then we can much easier or easily said that, or you can say that diagnosis is much more convincing. So multimodality is one of the main frontiers of new foundation model revolution. So our models, the deep learning models that we are basically using for understanding and expressing, generating, analyzing, the multimodality is one of the major characteristics, or you can say the deep learning model should become multimodal in nature. Now we try to understand what are the applications of multimodal approaches. Let's say we are dealing with two modalities, text and images, which is very relevant to this course. Now, if we say retrieval means it is input is image, we can retrieve some text, or the vice versa, that we generally do in our Google search very frequently, that given some text to retrieve some image. So you can see there is two different modalities. One is image, another is text. And we do this thing very, very frequently in our daily life, mostly in academics, entertainment, research, and so on. Another very important multimodal application is image captioning. That input is image, and we have to have come up with a text that somewhat describes the image, or at least say something about image. So it's called image caption. Now text-based image generation, that is now very popular for this kind of our LLM based GPT tools or other tools, that some text prompt is being given, and based on this text prompt the model will generate the image. Another very important application areas is VQA, or visual question answering. That one image is being given, and related to the image some question is being asked. Model is going to answer this text, answer the question as a text. So you can see here there is one modality is being given, and we are getting output in a different modality. But here two modalities, so there is some fusion kind of thing is given, and model understand analyzing both the modalities and give in another modality. So multimodal classification is same. The image and text are being given, and based on this we can give some label to some particular class. Now image generation, better understanding, image plus text or label or text, this kind of thing. So what we can understand that this multimodal, or it's a bimodal in this case. There is a several applications, and these applications are very much relevant to not only to this course, but the very this modern and recent scientific understanding of NLP and vision, basically when where deep learning is being concerned. So one thing is very important, that multimodal data understanding, analysis, generation, and so on, these applications are very important for the recent days deep learning based vision, NLP and so on courses and studies and researches in industry applications. In a recent paper, the title of this paper is "Language is Not All You Need, Aligning Perception with Language Models." Here we can see that only one modality is we are not considering. We will go for other modalities also. If there is a text paper, text based, we can include vision or audio, video, whatever. So one thing we can understand, the multimodal is an emerging topic at this moment. Now, what about the different modalities? So information across different modalities often exhibit diverse characteristics, structures and forms of representation. Here you can say that the homogeneous modalities. What do you mean by homogeneous? That images from two cameras, since both are images, both are similar kind of input modality, it is more homogeneous. They are taken to different viewpoint. In that respect, that is heterogeneous. But it is more like similar qualities because both are images. A text, the meaning is same, but it is expressed in a different language. In that way, it is bit heterogeneous, but mostly homogeneous. But if take the two complete different thing, one is language and one is vision, that is more heterogeneous, and so on. So in a bimodal representation, this homogeneity and heterogeneity planning is very interesting. So abstract modalities are more likely to be homogeneous. That is some observation we can make. Now, what is the mean by dimension of heterogeneity? You can say information across different modalities often exhibit the diverse, what we have seen last slide, forms of representation. Now, in this figure, if it's a laptop centered on a clean desk with a mouse and a notebook beside it, that just describes this. So what is the elemental representation? What element-wise representation? Maybe discrete, continuous, maybe granular. So you can say there is some sort of laptop, mouse, that kind of tables and chairs and so on. So laptop, center, desk, mouse, notebook, besides. These are the way we represent the different information across the model or different modalities. So the dimension of heterogeneity be figured out in this way. It is a bimodal. So element representation, it may be discrete, continuous or granular. So in this way. The element distributions, that density, the frequency, how dense this modality or how frequent it is coming. That is another kind of understanding. Just for example, if we say that a number of head count in a gallery is quite dense situation, and if we say that there may be the number of or the distance between atoms in a body. So in this way actually. So the structural, it may be a temporal, it may be a kind of hierarchical, it may be a spatial kind of structure. That entropy of the some modality is very high, some modalities is low. So it's a information content wise. How noisy it is, it may be more noisy, and the relevance, task complete, context dependence, you can say how information is dependent on this particular or context is dependent. So these are the dimension of heterogeneity. That is important to understand. Now, it's very important to understand that how modalities are connected to each other. So connected means share information that relates modalities. Now say the modality A and B. Now there is a shared information, there is intersection between this. This part is unique, this part also unique, and this is intersection. So what is that strong connection if the intersection part is big? It's a weak connection, that is intersection part is big. And when it's unconnected, it is a both. There is two disjoint set. As of the statistical point of view also, if there is an association, the correlation, co-occurrence, this is the way how much a modality A correlated to the modality B. Or another is the dependency, that causal, temporal dependency, causal dependency, temporal dependency, how much the modality B depends on the modality A. On the similar, in the case of the semantic representation, there is the correspondence, that how both are grounded or both are related. Or relationship, is it this modality used for this? It's a function kind of thing. So these are the way the modalities are interconnected, that we have to understand, that how it is related or interconnected. Now interacting modalities. Interacting is also very interesting. Interaction, the process affecting each modality, creating a new response. So what is very important, two modalities is there. When they are connected, so this connection, this kind of, if we fuse these two modalities, can we get some new thing? So that interactions of these two modalities can develop a new information that is not explicitly viewable or explicitly learnable from these two modalities. So that is the inference kind of. And Z is this. It's a new kind of thing we are getting. So interaction happens during inference. Okay. So inference examples: representation, fusion, prediction task, modality translation kind. So what we require to understand is that if we can fuse these two modality, maybe we can get some extra information, extra knowledge, and the representation, prediction, modalities, something like that. So that is the called interaction between modalities, and some novel knowledge, a novel thing we going to get. Now we are going to understand the taxonomy of interaction response. This is a behavioral science view. Now what we have understand, that the two input modality, if we fuse it, we can get inferences, some new things. And it is, for example, a multimodal communication. That when we communicate, we are getting some knowledge or extra thing that understandable by both the we are basically talking. Now, how we are going to, if there is a two redundancy, first you have to do the bimodal responses, and it is a redundant. A is this and B is also this. Now, one thing, this is equivalence. Both are the same information kind of, or both modalities basically convey the same information. So, no extra thing. But if we add it, somewhat additive, so some enhancement is there. So, some better response we get, greater response. This is in redundant case. Case for non-redundant, both are different. Then A plus B maybe just is independent. So, A this and this. And there is some dominance, that something is dominating this other. So that is another kind of. Or another thing, modulation kind of. That if we are to somewhat modulated, so we can get some bigger response, or smaller, or you can say some emergence kind of. So new thing we can get out of it. So this is basically the texture of the interaction responses. Okay. Again, we revisit our questions. The main question: what is multimodal? So, in research perspective or scientific perspective, multimodal is the scientific study of heterogeneous and interconnected data. So, interconnected means connected and interactive. So, the thing is that how multimodal machine learning and multimodal AI are somewhat defined. So, one thing we can understand, then maybe a multimodal machine learning and AI is kind of a very similar thing, but definitely there is some difference. So, multimodal machine learning focuses on algorithms that learn and improve by leveraging data from multiple modalities. So, we can understand that there is some machine learning algorithms, maybe our conventional machine learning algorithms and recent deep algorithms, that are basically taken at different modalities and then get some inference, or you can generate some data from that. On the other hand, multimodal artificial intelligence or multimodal AI studies systems that exhibit intelligence. That is, for example, the understanding, reasoning, planning by integrating the multimodal data and experience. In a normal case, AI is kind of a superset of ML, or ML is a subset of AI. But in this, from our point of view of, or our discussion point of view, it is more or less similar thing. So multimodal AI is a superset of multimodal ML in general. Now, what we try to understand first, that what do we mean by multimodal machine learning? So the language, I really like this movie, if we say this. So there is some vision, is there some video clips of this, some acoustic. So the idea is basically here that this kind of thing we can represent it. There's a modality A, modality B, modality C in that way. Okay. So we can, here you can see that these are three different type of modality we are considering here, and we can use the multimodal machine learning. We can get some inference. Now the question is that what we mean by this inference. Sometimes it may be we can basically just fuse this information, we get some new information, or we concatenate, or we can get some generate the new data. The multimodal machine learning at itself may be unsupervised, may be self-supervised, be supervised, or reinforcement, and so on. But whatever the way we are taking, but we are basically taking these modalities and information in different modality and try to fuse to get some new information, maybe some inference, or to generate something. So that is the basic idea of multimodal machine learning. Now, it's a very important concept of multimodal machine learning, that what are the core multimodal technical challenges we are going to face or basically understand in conventional machine learning. Okay, that is very important or interesting topic. That the basic idea of this topic is that when we do the multimodal analysis or we do the machine learning modeling using the multimodal data, what are the basic challenges we are facing? Now, first is representation. Now, representation is a very important task or very important challenge of any machine learning or deep learning. As we know, there is a certain difference between conventional machine learning and deep learning. In the conventional machine learning, what we are basically doing, we are doing the feature engineering. That features are basically going to processed or going to enumerate manually, and these features are fed to these neural networks or SVM or any kind of these machine learning tools to get some prediction or inference. Now, the representation by definition, learning representation that model cross-modal interactions under the concept of the multimodal thing among elements from different modalities. Now, that is very important understanding, that cross-modal interaction among elements from different modalities. So, this is a core building block of the most multimodal modeling problems. We have to try to know why and how actual the representation learning, the core essence of this point or if this study is that how representation learning are being done in case of multimodal scenario. Now let's say a bimodal case, what maybe one text, one images. Now in modality 1 there is a sentence and let's say there is the individual element. So let try to understand our simplicity. These are the words of a sentence and these are the maybe very simplistically the image patches, or you can say some objects, whatever. The question is that there is a situation that what we are basically try to understand that cross-modal interactions. Now, it is not always the case that this temporally, this you can say in this two are interacting. It may be this interact with this, that interact with that, but that we'll see later. But the initial thing is that individually these submodules, okay, what they are doing is giving, it has been seen as a local representation of that particular modality. If it is a word, that word is being given a very local understanding of the full sentence. Whereas if it is an object or as an image patch, it's a local understanding of an image. Now the question is that it may be interacting or there is maybe different interactive patterns of this. Okay, but these local representations or this representation or submodules are basically represent using the holistic features. So it's a part of feature, but it basically doing the local representation, and that is we try to understand how. Now, as we have seen that representation is basically, or we can say the multimodal representation learning is basically reflect the cross-modal interactions between individual elements across different modalities. Now, it may be possible that three different cases, some fusion, when these are two fused, we can get a features kind of thing. Now, in generally, when we are fusing, in this called fusion techniques or fusion challenge, the modalities, the information content abilities is greater than the representation. So this is the representation kind of thing of these two modalities. Now here the coordination. Coordination is basically that modalities and representation are same. So these represent this, these represent, but this is already, you can say that this is the both thing. These are interacting, already interacted. And fission is that the modalities is basically generating something that is bigger. This representation is bigger than this. For a very simplistic or hypothetical case, you can say we can get two modalities, we can fuse it, or we can fission kind of thing is, and you can get some more with elaborated feature space or more higher feature space that better describe the representations of this individual or kind of the combined model, multimodal data. So this is the representation. Our next challenge is alignment. So what will be my alignment? Alignment means that let's try to understand here first, then we'll come to the definition. First of all, alignment means these submodels or this we should say submodules is may not be very much one-to-one consistent, may not be one-to-one consistent, the temporal direction. There may be some cross kind of thing here. So how this alignment is done between this successive modalities kind of in temporal direction. So by definition, identifying and modeling cross-modal connections. So these two are cross-modal between all elements of multiple modalities. So building from the data structure. So these are two different kind of model. For simplicity, you take the bimodal data, two modalities, maybe a multiple modality. And what we are trying to understand, that the interaction between these modalities. So most modalities have internal structure with multiple elements. Now this is the idea that how these two submodalities are interactive, or what is the relation between them. Now again another kind of thing you can say, within an image it is a single, that some part of these images may be interactive. You can say this person is basically playing this ice hockey or something, that is putting this ice hockey stick, and this is the ball or something like this, and wearing the gloves, some helmets, some jackets, and this images is basically within an image there is a multiple object or multiple models that is also somewhat related or interacting. Okay, some concept of the human computer interaction kind of thing. Here we can see that can we find out that what is basically this or action recognition kind of thing. So within a image there is some sort of different modalities, and these submodalities are somewhat have connection introduction. This connection introduction, this is a spatial, maybe the hierarchical also. This may be the across the modalities also. So these things is called alignment. Now what are the subchannels? The discrete alignment, that means that one to this and this and this, there is no continuous kind of thing. The discrete elements and connections. So these are the discrete element, and how this connection is also discrete. But sometimes it's a continuous alignment. The connection is this kind of, but from this we can get this continuous kind of waves or some frequency. So segmentation and continuous wrapping. So this is most important one, is very important thing in modern papers and modern, that contextualized representation. Now can we find that some context out of this by aligning these two modalities or bimodal or multimodal data? So alignment plus representation, that is very important, because not only we are represent, we are try to find the how they are aligned. So that is going to give you some context and or context representation. Initially, what were this is become representation learning. Now we are not only learning the representation but the context as well. So that is the contextualized representation, and by virtue of this alignment. Now next comes the reasoning. So reasoning is basically that within a can say machine learning, what is happening. Nowadays it is a deep learning kind of. As we know that we do this, we already discussed this, that we do in conventional machine learning what we engineer or what we generate these features. That is called feature engineering, feature generation, feature extraction. So combining knowledge usually through multiple inferential steps, exploiting multimodal alignment and problem structures. Now why we are saying this complicated thing? Because that in deep learning it is done automatically. So when there is a multimodal data, we are doing this kind of interaction with this kind of alignment, this kind of representation, so we can get the feature out of this. But this is done. So another very important thing that we have to understand what these layers do. These layers is basically doing, if we say the multimodal data, they are doing this kind of thing. They are represents the data, this alignment their data, and they try to find out that within these submodules what are the first representation and how these representations are aligned. And by this alignment of the representation, how we can get the context or contextualized representations of this. And that is basically initial layer is more rewarded. When we go to then this permutation combination is basically rapidly, and this is some logical thinking or logical flow in this, because in case of this supervised nature, this kind of is going to, we can get this intended output, and after that we can get a feature. This is after ready planning, this is ready planning, CNN features or a kind of reasoning features kind of thing, or ultimately we infer something. So this is the reasoning. Now here you can say combining knowledge usually through multiple inference steps, that we have seen the reasoning, putting multimodal alignment and problem structure. So another case you can say, now what we are basically trying to discuss at the different level, how actually things being done within a kind of deep learning model. Sometimes some external knowledge also playing a very important role here. Okay, so this may be using this particular external knowledge. So that is very important to understand that what is the point of this external knowledge. So what is happening here, that we can get some sort of representations of this, of multimodal data, and we can get some out of some features here, and these features we are again fuse, and then we again some extra features in the next layer, and in this is going on, and with the help of some external we can out of get this, or this. Okay, so this is the basically reasoning behind this. Now what are the sub challenges? The structure modeling, that what we this is the structure modeling, how actually we are going to find out the way of aligning of these different representations of submodalities. So the structure of this, then intermediate concept. What are the intermediate things? These are the intermediate steps, words and this. So these are the intermediate steps, how that also we have to define there. And the inference paradigm, how do we going to infer this? These are these true or and external knowledge. But one thing is very important. In case of deep learning model, this we are not doing. It is doing some automatic things is being done here. Okay, so that is very interesting to that from the multimodal point of view. Single modality we can, but multimodal things become more and more complicated. That is very interesting study. Now, in case of generation also, that we can find the same challenges, that the learning generative process to produce raw modalities that reflect cross-modal interaction, structure and coherence. That means when we are generating something, so it's a generative kind of process that which these multimodal deep learning models are generative in nature. So there, what kind of generation? Maybe something summarization. There is some image modality, some text modalities, and we can summarize it. We can do it. Summary. Or it may be a translations. It may be maybe in one modality. Image to text, or by text to some image or some translation, or creation kind of thing. Given some feature space, we can create modality of the multimodal data. So here some summarization, you can see that there is some sort of reduction of information, while maintenance is basically the equivalent or kind of equal. Or creation, generally we can get the bigger data. So what we are generating, that is bigger than the input modality or the information content point. Okay. Now the last thing is come the transference. Not last, is the fifth point is transference. Now transfer knowledge between modalities is transference. Usually to help the target modality which may be noisy or with limited resources. Now we can say that is the modality A. There is some noise or something like that. Okay, so modality B is basically available at the time of training to find out that if there is some sort of noise or some sort of data is required to understand this, that will helping to get the better or enriched modality A, and that is called the transference. Some images is there, and there is some text that is going to help to understand this image correctly. Maybe a noisy image, so it will give. So this is called transference. So definition wise, transfer knowledge between modalities, as we said, that usually to help the target modality which may be noisy or with limited resources. Now this sub challenge is transfer. You can say that this is the transfer in. So here you can see that this will transfer, that will transfer this, and this is the co-learning by representation, that this modalities is there and they are trying to find this kind of concept of co-learning. By this is co-learning by representation, and this is the co-learning by generation. So this is basically, and there is some sort of co-learning which generate this. So this is called a transference. Okay. And finally, this is a quantification. The empirical or theoretical study to better understand the heterogeneity, the cross-modal interaction and multimodal learning process. So sub-challenge is this kind of heterogeneity is there. Some interactions, you can say, and some learning, the loss book. So this is basically try to find out what is the heterogeneity being this, or interaction patterns. Or now if it's a full pitch figure, if we consider, so this is the representation kind of and alignment, and this is kind of a things that we can say input for this. Then coming to the reasoning, and that is when we are basically doing this training or learning phase, and we can generate a transference. Ultimately we quantify that how much we can get that this loss or something. So this is the core multimodal challenge. At the different layer of machine learning or AI, station based understanding or learning, that how these 6 points are very important. Okay. So in this lecture, what we have understand, we define what is multimodality. Then we try to find out what is research-oriented definition, dimension of multimodality and heterogeneity, and modality, connections and interaction. Then we try to understand core technical and conceptual challenges of multimodality, representation, alignment, reasoning, generation, transfer, and motivation. So in the next lecture, we understand what is the multimodality models. Thank you very much.